To help explain the idea of force projection, we are going to do an example problem. In this example problem, we have a force going down cable OA, and we want to know how much of it is going down rod OD with the given information. The process that I follow when I am finding the force projection is to find the unit vector of the axis we are projecting onto first. Then I look at the force and realize that it is in Cartesian notation, and so I need to get the unit vector of the force in order to be able to break it up into its components. Next, I'll find the force projection directly by using the equation that FOD is equal to F1 times the dot product between the unit vector of OA and the unit vector of OD, which means that the force projected onto the axis OD is simply the magnitude of the force multiplied by the dot product between the two unit vectors. Then I will find the projected force in Cartesian notation by multiplying the magnitude of the force by the unit vector of OD. Now I'm sure you're all curious where I got that formula from. It's actually derived from the process that you normally do. All you have to do is see that the force would equal the magnitude multiplied by the unit vector OA. Then you would do the next step, which is to take the dot product of the unit vector OD and that force. Well, if we were to substitute what FOA is equal to into this formula, you will get the formula that I showed you earlier. Now all we do is follow that process. We'll begin with the unit vector of OD. I've seen several students get caught up on this concept. For some reason, they think that the unit vector can only be done with the position vector or the force vector. What we know about the unit vector is that it's actually a direction vector, which means that whatever magnitude you multiply by, you will get the Cartesian notation for that vector. It basically tells you how much that force or that vector goes in the x, y, and z directions. I think of those arcade games that kids used to play in high school when you wanted to launch some kind of projectile, but you had to indicate what direction you wanted the projectile to go into and how much power you wanted to put behind it. It didn't matter if you put more or less power into the projectile, it would follow the same initial path, because that was the direction you fired it in. You can think of that as the direction or unit vector. Looking at this problem, we notice that OD does not have any lengths. But those aren't needed. We just need the direction. If we did have a length, it would just cancel out, and we would be left with just the trig identities of that bar, like this. Next, we have to find the unit vector for OA. In a more traditional fashion, since it gave us all the lengths, we will have to take the Cartesian position vector and divide it by the magnitude in order to get the unit vector. Then we will perform the dot product and multiplication to get the magnitude of 3.47. Then to find the dot product in Cartesian vector format, all we do is multiply and we get our final answer.